Hello. Now we are going to look at multiplying fractions. Whenever we're talking about multiplication, we're talking about groups of things. So if we had the multiplication sum 2 brackets for multiply, 5, we know that that would mean 2 groups of 5, which would give us 10 units in total. So each one of these little boxes would be 1 unit. So we'd have 2 5s would be 1, 2, 3, 4, 5, and another group of 5, 1, 2, 3, 4, 5, and in total we count up having 10 units in total. Now we're going to come back to this sum in a moment when we've had a look at some fraction multiplication, but our multiplication has always meant and will mean that we have groups of things. But what does it mean if we have less than one group of something? That's what we're going to look at now. And what we effectively do is say, how many pieces do we have of our group? So if we want to say we have a third of 6, so 6 is still a whole number, but we have a third of 6, well, that would be the same as a third multiplied by 6. So we're going to do this visually first. What would that mean? Well, we have a group of 6 units. So we still have whole numbers there, and we're going to get a third of that group. Well, that means we're going to break the group into 3 pieces, and we're going to keep one of them. That's what that means. So we're going to break the group. We have our 6 units here. Each one of these blocks is 1 unit, and we're going to break it into 3 equal pieces. So we break it up like that, and we are only going to keep one of these thirds, one of these broken up pieces, because we only have 1/3 of 6. So each one of these would be a third of 6. So we've broken it up into our 3 pieces, and we're only going to keep one of those pieces. So we keep, we'll say, this third here. So what does that leave us with? It leaves us with 2 units. And we probably instinctively knew that a third of 6 is going to leave us with 2. How do we write that out mathematically? Well, what we do is we say of is going to mean multiply in this case. This can be a key word we come across. Of is often going to mean multiplication in maths. So we have a third multiplied by 6. Now we know that a whole number its units aren't broken up. So they're effectively a group of 1. They aren't divided into anything smaller. So our 6 units means 6 units that are broken up into 1 piece each. They're not broken up. So that's how we can write both of these numbers, the third and the 6, as fractions. And we ended up with 2. So what we're going to look at now is why that ends up happening. Mechanically, how do we do a third multiplied by 6 all over 1? What we do mechanically is just multiply the top numbers together and the bottom numbers together. Using formal maths language, we multiply the numerators together and we multiply the denominators together. So 1 by 6, 3 by 1. And we do that multiplication and we end up with 6 all over 3. And then we can say, we see we have a common factor. So this is a fraction we can simplify. We have a common factor of 3. So we could write that as 3 by 2 all over 3 by 1. This is effectively an equivalent fraction argument. If we had 2 over 1 and we wanted to create an equivalent fraction, we could break it up into 3 pieces and have 3 times as many of those pieces and get 6 over 3. Simplifying is the reverse of that, and we end up with having just 2 over 1, which we usually call 2, which is what we figured out from our picture. Now, if we go back to our original question here, we had 2 groups of 5. The 2 was a whole number, so it was 2 whole groups, and you had the 5, which was 5 whole units, 5 whole groups, and that ended up being mechanically the same as 2 by 5 all over 1 by 1, which ended up being 10 all over 1, which we call 10. So our whole numbers work exactly the same way. We just never had to think about what was going on for our denominator numbers because our groups, our units, were always broken up into ones or not broken up. They were just left as whole units. So we didn't have to think about 1 by 1 being 1. But we have implicitly, secretly, been doing fraction multiplication in that sense all of the time. Now let's have a look at what happens if we have fractions multiplied together, or things that are obviously fractions multiplied together. If we wanted to get a half of a third, that's going to mean a half multiplied by a third of, often means multiply. How would we do that visually? Well, I have taken my unit is going to be this whole bar here, and I have broken it up into 3 equal pieces, and I've colored in one of them, so that's my third. If I wanted to get a half of a third, I would need to break this up. In the same way as I had my 6 units and I broke it up into 3 equal pieces, I'd need to break up my third here into half, and then I'd need to figure out what fraction of a unit that would be. So I'm going to draw that in. I'm going to break up my thirds blocks here in half. So by breaking my thirds blocks up into half, so I've broken my third into 2 pieces, and I'm only going to keep one of them. So what I'm now going to say is I have broken up my third here into 2, and I'm only going to keep one of those 2 pieces. So now what fraction of a unit am I left with? Well, I have 1 of 1, 2, 3, 4, 5, 6. I have 1 out of my 6 pieces that I would actually keep. I have kept half of the third, which ends up being 1/6 of the total unit. So that's how I can argue this visually. What does it look like mechanically? Well, it's basically the same as what we've done for our whole number. We'd have half multiplied by 1/3 is going to be the same as 1 by 1 all over 2 by 3. So top by top, bottom by bottom, or in more formal language, numerator by numerator, denominator by denominator. And I end up with a 6th using that method as well. What happens if I want to get 2/3 of 4/5? So now we're getting into much more complicated looking fractions. I can write that as multiplication. I don't need to have brackets around both of these, so I've just highlighted that fact by just putting brackets around my second fraction here. If I have a number sitting next to a bracket, that means multiply. So I want to get 2/3 of 4/5. This large rectangle here is my single unit, and I have colored in 4/5 of it. How would I get 2/3 of the green section? Well, I can't easily figure out what a third of these 4/5 is. So what I'm going to need to do is break up my unit into more pieces. I'm going to need to actually break it up into 15 pieces. So I'm going to break up the unit into thirds this way and see how many 2/3 of this green group is going to be. So I have broken my unit into thirds going this way. And now I can see I have 1, 2, 3, 4, 5, and so on. I have 15 little pieces that make up the unit, and I want to get 2/3 of the green part. So what is that going to end up being? Well, I have the thirds lines going this way, so I could take these ones. That would be 1/3. That would be 2/3 of the green section. That's the 4/5, and I want 2/3 of that. So what fraction of my total unit would that be? That would be 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 15ths. So I have 15 little pieces all together, and I have 8 of them colored in for 2/3 of my 4/5. So that's going to be 8 15ths. All right. Going to be 8 15ths. Now, how do we do that mechanically? We just multiply our pieces together. So we'd have 2/3 of 4/5, and we just do top by top, bottom by bottom. So it's important we understand why this is happening, that we are breaking up whatever we're multiplying into 3 times as many pieces, and then we're keeping 2 parts of those pieces. So we have a total of 8 all over 15. So now we're just going to practice some more number examples. So we have 5/8 of 3/2. So we're just going to do top by top and bottom by bottom. We have 5/8 numerator by numerator, denominator by denominator, and we end up with 5 threes is 15, or 5 groups of 3 is 15, and 8 groups of 2 is 16, and that's our job done. Here we have to do a little bit of simplifying. We have, because we have a mixed number, we should also keep an eye, particularly as we get into more advanced questions, is there any simplification we can make to our fractions? But I can't see any obvious ones here, so we're going to just turn our mixed number into an improper fraction. So we have 1 is the same as 2 over 2, so we'd have 2 over 2 plus we would have 2 halves plus 1 half would be the same as 3 halves times 7 all over 5, and at that point we can just multiply top by top, bottom by bottom, numerator by numerator, denominator by denominator, and we end up with 3 by 7 all over 2 by 5, so we end up with 21 all over 10, which we could write as the mixed number. We'd have 2 groups of 10 would give us 20, so it'd be 2 and 1/10 left over. What do we have to do here? Well, we have simplification we can do. We have a common factor of 4, top and bottom for our fraction here, and we need to turn the whole number into a number over 1 so we can meaningfully describe it in relation to our other fractions. So we have to simplify this here. So we have a common factor of 4. So 4 by 2 is 8. 4 by 3 is 12. So we have our common factor. The opposite of doing our equivalent fractions, if we had 2/3, we could turn it into 8/12 by breaking it up into 4 times as many pieces and having 4 times as many pieces because we did it. So when we've done that simplification, this must be the same as 2/3. We have 3 over 1. Then we do top by top, bottom by bottom. We might be able to see that there's a common factor of 3 here and just simplify immediately, but we could also write that down as 6 all over 3, and then we'd be able to take out our common factor of 3, and we would just be left with 2 over 1, which is 2. We can also get our questions in English like we did at the beginning, where we have 3/4 of 8. So we are going to get 3/4, and we are going to have of 8, and that's going to be 8 units. So each one of those pieces is only broken up into one part. It's just left as whole numbers, so it's 8 over 1. And then we are going to do top by top, bottom by bottom. We can't see any simplification that we could make, so we just go straight to numerator by numerator, denominator by denominator, and we end up, we may be able to see a common factor of 4 top and bottom, and if we can, you can take it out, but we can also just say that we end up with 24 all over 4. We see we have a common factor of 4, so we'd be able to say that that is the same as 4 by 6, 4 by 1, so 6 over 1 is equivalent to 24 all over 4, because we could break it, our units, up into 4 pieces and have 4 times as many of those pieces. So that would be the same as 6 all over 1, which we would usually call 6 units. So that is how we do our fraction multiply. We break our piece that we are multiplying into a particular number of parts, and then we see how many of those parts we want to keep. So we broke this up into 8 times as many pieces, and then we are going to keep a fifth of those pieces, or 5 parts of those pieces. So that is how we do our fraction multiply, and that is what we need for now.